Jean-Baptiste Joseph Fourier was a French mathematician and physicist born in Auxerre and best known for initiating the investigation of Fourier series and their applications to problems of heat transfer and vibrations. The Fourier transform and Fourier's law are also named in his honor. Fourier is also generally credited with the discovery of the greenhouse effect. Biography: Fourier was born at Auxerre, the son of a tailor. He was orphaned at age 9. Fourier was recommended to the Bishop of Auxerre, and through this introduction, he was educated by the Benedictine order of the convent of St. Mark. The commissions in the scientific corps of the army were reserved for those of good birth, and being thus ineligible, he accepted a military lectureship on mathematics. He took a prominent part in his own district in promoting the French Revolution, serving on the local Revolutionary Committee. He was imprisoned briefly during the Terror but in 1795 was appointed to the École Normale Super-Copyright Rear, and subsequently succeeded Joseph Louis Lagrange at the École Polytechnique. Fourier accompanied Napoleon Bonaparte on his Egyptian expedition in 1798, as scientific advisor, and was appointed secretary of the Institut d'Egypte. Cut off from France by the English fleet, he organized the workshops on which the French army had to rely for their munitions of war. He also contributed several mathematical papers to the Egyptian Institute which Napoleon founded at Cairo, with a view of weakening English influence in the East. After the British victories and the capitulation of the French under General Minot in 1801, Fourier returned to France. In 1801, Napoleon appointed Fourier prefect of the Department of Auxerre in Grenoble, where he oversaw road construction and other projects. However, Fourier had previously returned home from the Napoleon expedition to Egypt to resume his academic post as professor at École Polytechnique when Napoleon decided otherwise in his remark. The prefect of the Department of Auxerre having recently died, I would like to express my confidence in Citizen Fourier by appointing him to this place. Hence being faithful to Napoleon, he took the office of prefect. It was while at Grenoble that he began to experiment on the propagation of heat. He presented his paper on the propagation of heat in solid bodies to the Paris Institute on December 21, 1807. He also contributed to the monumental description de l'Egypte. Fourier moved to England in 1816. Later, he returned to France, and in 1822 succeeded Jean-Baptiste Joseph Delambre as permanent secretary of the French Academy of Sciences. In 1830, he was elected a foreign member of the Royal Swedish Academy of Sciences. In 1830, his diminished health began to take its toll. Fourier had already experienced, in Egypt and Grenoble, some attacks of aneurysm of the heart. At Paris, it was impossible to be mistaken with respect to the primary cause of the frequent suffocations which he experienced. A fall, however, which he sustained on 4 May 1830, while descending a flight of stairs, aggravated the malady to an extent beyond what could have been ever feared. Shortly after this event, he died in his bed on May 16, 1830. Fourier was buried in the Père-Lachaise cemetery in Paris, a tomb decorated with an Egyptian motif to reflect his position as secretary of the Cairo Institute, and his collation of description de l'Egypte. His name is one of the 72 names inscribed on the Eiffel Tower. The Analytic Theory of Heat. In 1822 Fourier published his work on heat flow in the Copyright Analytic de la Chaleur, in which he based his reasoning on Newton's law of cooling, namely, that the flow of heat between two adjacent molecules is proportional to the extremely small difference of their temperatures. This book was translated, with editorial corrections, into English 56 years later by Freeman. The book was also edited, with many editorial corrections, by Dubou and republished in French in 1888. There were 3 important contributions in this work, 1 purely mathematical, 2 essentially physical. In mathematics, Fourier claimed that any function of a variable, whether continuous or discontinuous, can be expanded in a series of signs of multiples of the variable. Though this result is not correct, Fourier's observation that some discontinuous functions are the sum of infinite series was a breakthrough. The question of determining when a Fourier series converges has been fundamental for centuries. Joseph Louis Lagrange had given particular cases of this theorem, and had implied that the method was general, but he had not pursued the subject. Peter Gustav Lejeune Dirichlet was the first to give a satisfactory demonstration of it with some restrictive conditions. One physical contribution in the book was the concept of dimensional homogeneity in equations. That is, an equation can be formally correct only if the dimensions match on either side of the equality. Fourier made important contributions to dimensional analysis. The other physical contribution was Fourier's proposal of his partial differential equation for conductive diffusion of heat. This equation is now taught to every student of mathematical physics. Determinate Equations. Fourier left an unfinished work on determinate equations which was edited by Claude Louis Navier and published in 1831. This work contains much original matter. In particular, there is a demonstration of Fourier's theorem on the position of the roots of an algebraic equation. Joseph Louis Lagrange had shown how the roots of an algebraic equation might be separated by means of another equation whose roots were the squares of the differences of the roots of the original equation. Section Boudin, in 1807 and 1811, had enunciated the theorem generally known by the name of Fourier, but the demonstration was not altogether satisfactory. Fourier's proof is the same as that usually given in textbooks on the theory of equations. The final solution of the problem was given in 1829 by Jacques-Charles Section Storm. Discovery of the greenhouse effect. In the 1820s, Fourier calculated that an object the size of the Earth, and at its distance from the Sun, should be considerably colder than the planet actually is if warmed by only the effects of incoming solar radiation. He examined various possible sources of the additional observed heat in articles published in 1824 and 1827. While he ultimately suggested that interstellar radiation might be responsible for a large portion of the additional warmth, Fourier's consideration of the possibility that the Earth's atmosphere might act as an insulator of some kind is widely recognized as the first proposal of what is now known as the greenhouse effect. In his articles, Fourier referred to an experiment by de Saussure, who lined a vase with blackened cork. Into the cork, he inserted several panes of transparent glass, separated by intervals of air. Midday sunlight was allowed to enter at the top of the vase through the glass panes. The temperature became more elevated in the more interior compartments of this device. Fourier concluded that gases in the atmosphere could form a stable barrier like the glass panes. This conclusion may have contributed to the later use of the metaphor of the greenhouse effect to refer to the processes that determine atmospheric temperatures. Fourier noted that the actual mechanisms that determined the temperatures of the atmosphere included convection, which was not present in de Saussure's experimental device. Works: Fourier, Joseph. Copyright Analytic de la Chaleur. Paris, Fermin-Paris Phylze, Fourier, Joseph. Annales de Chimie et de Physique 27. Paris, Annals of Chemistry and Physics ppA 236 Euro 281 Fourier, Joseph. Copyright Moire sur la Tempe Copyright Raja du Globe Terrestre des Espaces Plana Copyright Terre 7. Memoirs of the Royal Academy of Sciences of the Institut de France ppA 569 Euro 604 Fourier, Joseph. Copyright Moire sur la distinction des racines imaginaires, et sur l'application des copyright Auxerre d'analyse alga copyright Brico copyright Quations transcendence qui da copyright Penda de la copyright Henri de la Chaleur 7. Memoirs of the Royal Academy of Sciences of the Institut de France ppA 605 Euro 624 Fourier, Joseph. Analyse des copyright Quations da copyright Termina copyright is 10. Fermin-Frares ppA 119 Euro 146 Fourier, Joseph. Remarques gar copyright na copyright Rail sur l'application du principe de l'analyse alga copyright Brico copyright Quations transcendence 10. Paris, Memoirs of the Royal Academy of Sciences of the Institut de France ppA 119 Euro 146 Fourier, Joseph. Ma copyright moi d'analyse sur le mouvement de la chaleur dans les fluids 12. Paris, Memoirs of the Royal Academy of Sciences of the Institut de France pp. 507 à 530. Fourier, Joseph. Rapport sur les tontines 5. Paris, Memoirs of the Royal Academy of Sciences of the Institut de France pp. 26 à 43. See also, Fourier analysis, Fourier number, Fourier a de line transform, Fourier's law, heat equation, references. Further reading, initial text from the public domain Rouse History of Mathematics, Fourier, Joseph Theorie analytique de la chaleur. Firmin Didot, Fourier, Joseph The Analytical Theory of Heat. Cambridge University Press, Fourier, J.B.J. Ma copyright Moise de l'Académie copyright My Royale des Sciences de l'Institut de France 7. 570 à 604. The Project Gutenberg A Book of Biographies of Distinguished Scientific Men by Frena Section Moi Arago, Fourier, J. A. Permel Loge Historique de Sir William Herschel, Prononca Copyright Dans les Arts Copyright Ans Public de l'Académie Copyright My Royale des Sciences le 7 juin, 1824. History de l'Académie Copyright My Royale des Sciences de l'Institut de France, Tome Vi, Anna Copyright E 1823, PLXI. pg 227, external links, O'Connor, John J. Robertson, Edmund F., Joseph Fourier, Maxenter History of Mathematics Archive, University of St Andrews. Fourier, J.B.J., 1824, Remarques gar copyright na copyright rail sur les temps copyright rages du globe terrestre et des espaces plana copyright tears, in Annales de Chimie et de Physique, Volume 27, pages 136 à 167 à translation by Burgess. Fourier 1827, Memoir sur les temps copyright rages du globe terrestre et des espaces plana copyright tears, Université copyright Joseph Fourier, Grenoble, France, Joseph Fourier and the Vivazile mathsbank.co.uk, Joseph Fourier at the Mathematics Genealogy Project, Joseph Fourier Angstrom Uvers Completes, Tome 2 Gallica Math, Joseph Fourier, Thar Copyright Analytique de la Chaleur Google Books.